All right, folks, I wanted to show you today that your calculator has a way to double check all of your confidence intervals. I apologize for the weird quality of my screen today. So I want to show you how to do the first problem for the classwork, 16.5. It is asking you to double check with the calculator how to do the confidence interval. So this is about the crazy activity from a long time ago about Literary Digest predicting the wrong presidential candidate to win in 1936 in the heart of the Depression. So what happened was they got 2.4 million, so 2,400. That's how many people were in the study that responded, sent them mail in the middle of the Great Depression to tell them they were voting for Alf Landon, who we don't recognize because he did not win. So sample size was 2.4 million. The actual percent, the proportion of people in the study who responded and said that they would vote for Alf Landon was 0.57. When we get to the calculator, it's going to be a little tricky. So here's where you go. You're going to go to stat. We're going to go to the second part of the calculator. We haven't been using it. So we're in the part of the course where we're doing inference procedures, what statisticians do professionally. So we're going to the last column. It says tests. When you get here, you get a sequence of tests. These are hypothesis tests. We'll do that next. But below them, you get intervals. So we're going to scroll down, and we're looking for a one proportion z interval. So not this first one, this one, option A. So we're doing a one proportion confidence interval. So what you want when you get here is not a number we have. So instead of putting in your p-hat, we actually have to put in how many people said they would vote for this man. So here's, I think what what's suggested is we type in 0.57, 57% times this number in X. Careful with your zeros. I think that's the one. Now, it's really important that this is a whole number. So obviously with 1 million people, that's easy. But when you use this again for the other problems today in the classwork, you need X and N to be whole numbers. So if it's not a whole number, you've got to round it. Right? Just be careful. It will throw a very fancy error at you if that's not the case. So this many people out of this many said they would vote for the wrong guy. And then they wanted us to make a confidence level be 99.9. So we're going to go for 0.999. Okay, so that's the setup. How many people in your study said what? Out of how many? What confidence level you want? So when you're done, it will give you your p-hat, 57, give you your n, and then it gives you your confidence interval. So it asks us to do the calculator to get that interval. So for part A, I've got 0.56895 to 0.57105. So that's my 99.9% confidence interval. It's very narrow, and they're asking us to figure out why. Well, remember the formula. We've got p-hat plus or minus critical value. And then we have p-hat 1 minus p-hat over n. Well, the magical weird thing in this problem is this guy. You're dividing by 2.4 million. You're dividing by a gigantic number. So this standard error is going to be very small because you're dividing by 2.5 million. Also, the critical value, this critical value is going to be big for 9%. This is bigger, but this is just so much bigger than that. You're dividing by a huge number. So we're going to say for B, you're dividing by a very large number, sample size. So we have a small margin of error. Even though we have a high confidence level, which usually leads to wider intervals because we have a giant sample size. All right. Now, very important for today. In the actual election, 37% of people voted for Alf Landon. Why did this interval miss so hard? I hope you remember this, right? This is not at all a representative sample. And what that means is the center of this interval is super off the mark. So when you're doing a confidence interval, you want to do a one proportion z interval. which is what this is called in the calculator, the very first thing you do is you check your conditions. Condition number 1, a random sample. That was the big fail here. They sent mail to people who owned phones and cars in the middle of the Great Depression. Totally biased, not random sample, absolutely not representative. The first thing you do is check if you have a random sample, and that checks if your p-hat is close to where it should be, and this one was not. The second condition you have is n p-hat greater than or equal to 10, and 1 minus p-hat greater than or equal to 10. So, just a comment, this is checking that you're unbiased, that your center is good. This is checking that the shape of the distribution that you're working with is normal. If you meet this condition, that means that your z-stars are correct. Right, so you want to be checking those two before you decide that your confidence interval is valid. So for the rest of today's classwork, when it's asking you to check those conditions, start here first, then do the interval. That way you won't make a silly mistake where you do a bunch of work and you're like, wait, I failed at the very first bullet point. So when you do this, you want to say random sample is given, the study was random, check it off. And then for the NP hat, you would show the numbers. So this one, let's do it. Sample size is ridiculous. Times the p hat, which is 0.57, you're going to get a very large number. This is bigger than 10. Then you would check the people in the study who didn't vote for Alf Landon. Those guys are on the right side of history. So that would be 57% said they would vote for him, then you have 43% who didn't. Again, this is a huge number, bigger than 10. I am comfortable that my z-star is correct. So good luck. Try the other problems for today. Use that calculator double check you, so it'll help you go a little faster.